Welcome you all to the video practical series. Here we perform the experiments of different laboratory subjects. I am Professor Amit Kumar Patil from Department of Electronics and Communication Engineering, School of Engineering and Sciences, MIT Art Design and Technology University, Pune. Today we will perform experiment of the subject Digital Signal Processing Laboratory. The title of the experiment is Linear and Circular Convolution of Discrete Time Sequences using MATLAB. So let us come to the experiment. So here we have to perform an experiment, write a program to calculate the linear and circular convolution of two discrete time sequences. So basically signal are of two types. One is the continuous time signal, which vary continuously in the time domain. Second is the discrete time sequence. Here the amplitude exists only for at some specific time intervals. For such two discrete time sequences, we have to calculate the linear convolution and the circular convolution using MATLAB. So linear convolution is a mathematical operation which takes two signals and produces a third signal. It is used to describe the relationship between the input signal, impulse response, and the output signal. It is the process by which we can compute the overlapping of the two signals. It is also interpreted as the area shared by the two graphs over time. So for the two sequences, one is the input sequence xn, another is the impulse response hn. Linear convolution is given by the formula y of n is equal to x of n convolution h of n equal to summation k equal to minus infinity to plus infinity x of k h of n minus k. So basically here will be two sequences x of n and h of n. One sequence we will take as it is. Second sequence we have to time shift the sequence, multiply the two sequences and take their summation. So here different operations are involved while calculating the linear convolution. For example, time shifting, then multiplication and their summation. So first we have to fold the signal, then time shift it, then multiply it, then summation, then we will get the linear convolution of the sequences. So here the sequence length may vary. Two sequences can have the different length. So it is calculated by the formula. To calculate the number of sequences, we use the formula n is equal to n1 plus n2 minus 1. Suppose the xn has number of sequences 4. H of n has number of sequences 3. So 4 plus 3 is 7 minus 1, 6. So total 6 values we have to calculate while calculating the linear convolution. Now let us come to the term circular convolution. So it is also known as cyclic convolution. It is the convolution of two periodic functions that have the same period. So here the condition is that both the sequences should have the same number of values. Okay, means for first sequence has 4 values, second sequence must also have the 4 values. But if the second sequence has less values as compared to the first sequence, then we have to add number of zeros in the second sequence so that their length will become equal. So circular convolution is defined for periodic sequence whose convolution is the circular convolution for the two sequences is given by the formula x3m is equal to x1n convolution x2n, that is given by summation n equal to 0 to n minus 1 x1n x2m minus n comma mod n. So here we have to circularly shift the signal. The difference between linear and circular convolution is that here the sequences will be shifted linearly, but here we have to, in circular convolution, we have to shift the sequences in circular order. Here the number of sequences in linear convolution is given by the formula n is equal to n1 plus n2 minus 1, while in circular convolution, capital N is taken as maximum of the length of L1 and L2. Okay, so in this way we can apply the formula and we can calculate it theoretically, but now we have to perform this experiment on the MATLAB software or tool. So we have to write a code for linear convolution and circular convolution and calculate the result. So let us come to the MATLAB software for performing this experiment. So here first we will perform the experiment for linear convolution, then we will come to the circular convolution. So how we will perform the experiment? First we will take two sequences. We have to take input from the user. We will take input from the user for the first sequence, then plot the graph of the signal. Then we will take input from the user for the second sequence, plot the graph of the signal, apply the formula of linear convolution and calculate the result. In the same way, we will go for the circular convolution. So first, we will take input from the user to generate the first sequence. So here we have to write the command x equal to input, enter the first sequence. So this input will be taken from the user. After this, here we want graph, our graph should come in one window. One window should open. In this window, at first position, we should get the graph of first sequence. At the second position, we should get the graph of second sequence, and at the last position, we should get the convolution graph. Okay. So here, for fixing the position, I have to write the command subplot. So subplot, we want a window of 3, 1. Okay. So there will be 3 rows in one column. And at the first position, we want the graph of the signal. So we have to write 3, 1, 1. Now to plot the graph of the signal, since it is a discrete time sequence, here we have to write the command stem. So stem x will be the command. And after this, we have to give the labeling to the graph. For x-axis, y-axis in the title. So you have to write the command x label. So here we are taking the number of samples on the horizontal axis, and then y label. So here we are taking the amplitude, and then we have to give the title of the graph. So title of this graph is the first sequence. Okay. So even if you want, we can run this portion of the program. So here we have to enter the first sequence 1, 2, 3, 4. Okay. Now let us come for the second sequence. And here we can see the graph is also plotted. Now let us give the input, take the input from the user for the second sequence. We will write here y is equals to input, y is equals to input, enter the second sequence. Okay. And then we have to fix this position, write the command to plot the graph of the signal, and title and label. So we will copy and paste these things, enter the second sequence. Here we want position should be second, and stem we have to change here y, and here title we have to give it is the second sequence. So we can run this portion of the program. So run it. So enter the second sequence. Suppose we give 5, 6, 7, 8. Okay. So this is the second sequence. First sequence is open and second sequence. We will run it again. This portion of the program. First sequence 1, 2, 3, 4. Second sequence 5, 6, 7, 8. Okay. So now let us come to the convolution. So to calculate the convolution, here we have to write the command z is equals to convolution of x, y. This is the code to calculate the convolution. And after that, we have to plot the graph. So its position, we will plot it in the third position, 3, 1, 3. And then for plotting the graph, command will be stem z. And then we have to write x label, y label, and title. So x label number of samples, y label amplitude, and title will be the linear convolution. So run. So enter the first sequence 1 2 3 4, all also we can separate it by comma. Second sequence 5 6 7 8, and here you can see you will get the convolution. So here this is the result for the convolution. Also if you want we can display the result. So for that you have to write the command display the result. Okay, so display Z. Now run it again. So 1 2 3 4 is the first sequence, then second sequence 5 6 7 8, and then display Z. Value of Z we have to write here. Run the code again. First sequence, second sequence, and this is the result. Okay, so this we have calculated the linear convolution of the T sequence. So this is the first sequence, then second sequence, and finally the linear convolution of the two sequences we have plotted here. To make more clarity, we can also put the grid lines. So I will write the command grid on. Again run the code. First sequence, second sequence, and this is the result. And here you can see grid lines are also there for the proper readability of the experiment. Now let us come to the part of the circular convolution. So what is the difference between linear and circular? For circular convolution, it is calculated for the maximum of the length of the first sequence and the second sequence. So in linear convolution, the formula, how many values to be calculated, that is n1 plus n2 minus 1. So first sequence is of 4, second sequence is 4, 4 plus 4, 8, minus 1, 7. So 1, 2, 3, 4, 5, 6, 7 values are there. While in circular convolution, it will take the maximum of the length of the first sequence and the second sequence. So some changes we have to do in the linear convolution code to get the code for the circular convolution. So what is the changes? Here you have to write Z is equal to convolution x comma y comma capital N. X comma y comma capital N we have to write here. Okay, what is this capital N? Capital N is the maximum of length of first sequence comma length of second sequence. Means if their length are of variable values, then it will take maximum among them, and we have to calculate the length of first and second sequence. So length of first sequence will be given by L1 is equal to length of x1, and L2 is equals to length of x2. Okay, so these 4 lines we have to add in the linear convolution code to get the code for the circular convolution. So let us run the program. Enter the first sequence 1 2 3 4, then enter the second sequence 5 6 7 8, and here we have to write the code. The code is C. What is the code? Code is CCONV. CCONV for the circular convolution. Again run the program. First sequence 1 2 3 4, second sequence 5 6 7 8, first length is of x and second length is of y. Here is the result. Okay, so in this way we can calculate the circular convolution for the two sequences. And here you can see the graph for the circular convolution. And here in the graph we can make the changes. Title is circular convolution. So just replace the word linear by circular. Run the code. Second sequence. And here you can see the result for the circular convolution. Suppose you give the variable length. If I again run the code, suppose I give the length variable. Means suppose the length is not same. This is the first sequence length. Second sequence is okay. So for maximum length it will calculate the answer. Okay. So maximum first sequence length was 4, second sequence length was third, so it has taken the maximum length 4, and for this it has calculated the experiment. Okay. So this was all about the today's experiment, how to perform linear and circular convolution of the sequences. Thank you all.